Okay, so geometrically adding vectors. When we have multiple vectors that are undergoing on the same object, all we have to do is add those vectors together. This is a really common idea in physics called superposition. Superposition is very simple. Basically, the idea is that whenever we have multiple things that are affecting a situation at the same time, all we have to do is add those things together. So multiple forces pushing on the same object, what's the combined force? The sum of all those forces. Multiple velocities that the same object has from a frame of reference, what's the sum? All of those velocities added together. So we can add vectors together to get their total effect, which is pretty simple. And we do this by stacking them tail to tip. So you can do this by, basically, if I were adding this blue vector and this red vector here, if I were adding this blue vector and this red vector here, I would just stack them tail to tip. I would put the red one's tail on the blue one's tip, and then your resultant, the sum of your vectors, you get by starting from the tail of the first and going to the tip of the last. So the sum of this blue vector and this red vector gives me this purple vector. The tail of the red goes on the tip of the blue, and then when you're adding those, you just add them tail to tip, and then the tail of the first, you go from the tail of the first to the tip of the last. So we can do this mathematically, or geometrically, excuse me. We can also do this numerically too. So let's say, for instance, we have Steve and Tim pushing heavy furniture. The two of them shove on the same box in the same direction. Steve pushes the force of 9 newtons and Tim pushes the force of 14 newtons. What is the total net force on the box? This question is very easy. You could probably do this in your head, but go ahead and pause the video, give it a shot, and see what you think. Okay, welcome back. So Steve and Tim are pushing in the same direction. We have a vector of 9 newtons and a vector of 14 newtons. Oops, excuse me. We have a vector of 9 newtons and a vector of 14 newtons. So we have a 9 newton arrow and a 14 newton arrow. 9 plus 14 is 25. These will sum together to give me one 25 newton arrow in this direction. All right, pretty simple. And you guys probably know this from experience, right? If you're having trouble pushing something, somebody else can come up behind you and push too. It should track that the total force acting on that object is equal to the forces that each of you are applying separately. Okay, so let's try another problem. Again, this is pretty easy. You could probably do it in your head as well. Steve and Tim are both pushing on the same box, each exerting a force of 5 newtons from opposite sides. What is the total net force acting on the box now? So pause the video, try this one, come back in a minute. All right, again, this is pretty simple. Let's consider our directions here, right? So I'm going to call this direction the positive direction. I'm going to call this direction the negative direction. So Steve's force is 5 newtons in the positive direction. Tim's force is 5 newtons in the negative direction. So we could say Steve is pushing this way. Tim has the same magnitude and is pushing this way. So what is the net change in my arrow? It's 0, right? Another way we can think about this is I'm taking positive 5 newtons and I'm adding negative 5 newtons to it. What is that? That's 0. So this is like if you're playing tug of war and neither person is winning, right? You have equal forces, or arm wrestling works as well. You have equal forces acting in opposite directions, so the object isn't going to move. Those forces are canceling each other out because they're acting in opposite directions. And we could represent that by saying that if this direction's positive and this direction's negative, we just put that sign in front of the vector. So basically, the direction of the vector, the direction of the vector's tip points will determine the sign of that measurement, of that number. And that's all based on how you set your coordinate system up. Like I said, the classic one for Cartesian is positive x and positive y are up and to the right, and then negative x and negative y are down and to the left. Okay.